Hello, once again, it's Professor Elliott. This is, for now at least, my final JFET lesson, and we will continue looking at the self-biased JFET. So this will be by far the longest presentation. Not that it's hard, there's just a lot of little steps to go through. So thanks for stopping by today. Okay, in my last video, I gave you the current in the drain, and that kind of changes everything. That makes it simple. But what if we don't know the current in the drain? How do we calculate? How do we determine what it is? Okay, so this is much more practical. The last calculation was just to get used to the fundamentals, but this is more of an application. So again, the self-biased N-channel JFET. This is the circuit arrangement. Okay. Drain. Source. Gate. Okay. So and this should be VDD. It's 15 volts. RD is 1K. RS is 410 megohms. So this would be, and I encourage you to write this down. Okay. Everything right? Yeah, okay. Okay, we're going to plot the curve. Okay. So we're assuming our JFET has VGS off equals to 0, which means this is the point when the drain current is essentially equal to 0, so it's like cutoff. And the saturation current is 7 milliamps. So those are the two ends of the curve as the JFET goes from cutoff to saturation. Okay, talked about this before, this equation. So we're going to put different values of VGS. So if VGS equals to 0, the drain current at saturation is the maximum. Increase it to -1. Look, the current is falling all the way down. And again, put it back in that equation for each of these steps. Okay. Right, and the current eventually decays down to 0. And then you just simply plot that curve. Okay, so there's your curve, like there. Again, up here is the drain current. And then down here, I guess I should change the color. Gate to source voltage, drain current, saturation, and cutoff. You plot the curve. Okay. And the next steps. So see this blue line here. Okay, and this points 1 and 2. All right, so this is a complete graph. This is the actual Q point, okay, the operating point. So this is the real drain current and gate to source voltage, but there's some steps you need to get that point. So once you calculate, do your calculations for your drain current, you plot the red line. But now we have to determine what's this point 2 and 1. Okay, so copy this down, because it'll be much easier for you. So point 1 is we let the gate to source voltage equals to 0. Therefore the conduction channel is wide open. So the drain current's the drain current is, so this is a 0.1. Okay, so there's no drain current. So then therefore the gate to source voltage is 0. So this is always the origin. Okay, so 0.1. If you're doing a voltage divider, this is somewhere else, but for the self-biased, this is the origin. Okay. 0.2 is assume the drain current is at its maximum IDSS, which in this example is 7 milliamps. Solve for VGS. Now, do I have a diagram? Okay. So basically, it's going to be. Let's go this one. I have more room. Okay. Gate resistor. Okay, so then we're going to let the drain current be IDSS be a maximum, and then we're going to solve for VRS. So that's going to be, well, that's VRD, which we don't really need, but you can calculate if you want to. And this is going to be VRS. And this is 2.8. The gate voltage here, that's the gate to the ground is 0. This is not the same as VGS. See my last video. Oops. Like that. Okay, so if this current is 7, and this resistor I think was 400 ohms, it's 2.8, and that makes, so therefore that basically makes the gate to source voltage to be minus 2.8 volts, which is exactly what we need. Okay, and then that point there is 0.2, so I've came out to my graph to 2.8, drew this blue straight line up, that's 0.2, and then draw this purple line down, that's the straight line between 0.2 and 1. Where that line touches the transfer curve, that's our Q point. So this is our actual drain current and our gate to source voltage. Okay, so that's what we're doing here. Okay, and then I'm saying this is approximately 1.4 and this is about 4. Just, and the better you do the graph, the more accurate these are going to be. Okay, all right. Okay, solution steps. 1, solve for the drain current using various gate to source voltages. The more points you do, the better. So that's going to give you that. Okay, and this is the drain current. Okay, plot the curve. 0.1 is at the origin. Let the current be a maximum. Solve for the gate to source voltage. Right, and then plot it. Just go back to the graph, and then read the Q point from there. Okay. Right. So plot this curve. Sorry, I'm not very consistent in my colors, am I? Right. 0.1 is the origin. 0.2 is ID is IDSS. Calculate VGS. It gives you that point. Draw a straight line between 1 and 2. And then where the two curves touch, that's your Q point. Okay, midpoint bias. So this is what values of drain and source resistors do we need to set the Q point in the middle? That's at the 50% point. That's all this is. The circuit is the same, but what values of RD and RS are needed. Note the voltages and currents, so please sketch that down before continuing forward. Thank you. Okay, again, for our JFET, we'll assume the saturation current is 16, the cutoff voltage is -6. We'll let the drain VDD to be 10 volts, RG is 10 megohms. Calculate these two values. For a 50% Q point, these are standard formulas. The drain current is half IDSS, so we want the drain current to be 8. The drain voltage, so this is the voltage from the drain. This is the voltage literally from the drain to the common ground. It's half VDD, so we want it to be 5. Okay, that makes VRD 5. It's helpful if you have the circuit sketched. Okay, the gate to source voltage is the VGS off, that's from the data sheet, divided by 3.4 is 1.76. So what do I got? Did I do a diagram here? No, I didn't. Okay, so it's been a while since I did these slides. So let's go and sketch it here. Okay. So this is what these slides were, I don't know, 10 years ago maybe. I'm just sort of getting around now to doing a video. Hopefully it's helpful. Not as fancy as nearly as a lot of the other stuff I find online, but it's correct. It's my way of doing things. Okay. So basically VD we want to be 5, and okay, and VGS, I just want to switch colors here. We want to be minus 1.76. So therefore, if the gate to source voltage is minus 1.76, the source voltage, as we've seen before, is 1.76 positive. Okay? And if the drain voltage is 5 volts and the bias voltage VDD is 10 volts, that means then that the drain resistor voltage is obviously the difference between the two. That's going to be 5. Okay. And the drain current, IDSS was 16 milliamps. So half of IDSS is 8. So now just go ahead and calculate RD. And then calculate RS, and you have all the data to do that. Okay. Okay, and just put the numbers in. And now you just go back and, hey, right then. Then you just go back and plot the curve just the same way I showed you before to confirm those numbers are correct. Okay, have a wonderful day. Thanks for sticking around. Okay, bye.